code violations exist when branch circuits supplying a furnace or central air conditioning unit are used to supply other appliances or equipment as described in NEC 440.32. Also, NEC 110.10 states electrical installations shall be free from hazards that could cause personal injury or property damage. The situation described poses a significant electrical hazard when the television, irrigation system, and furnace are all operating simultaneously. The total current draw can exceed the capacity of the 44 amp breakers. This can cause the breakers to trip, interrupting power to critical equipment such as the furnace. If the furnace is operating during a cold night, for example, this could create an unsafe situation. There are several possible reasons why the previous electrician wired the subpanel and furnace on the same circuit. Firstly, the electrician may not have been aware of the code requirement prohibiting the use of furnace circuits for other loads. Secondly, combining the subpanel and furnace on the same circuit may have been an easier or more convenient way to wire the house. Thirdly, the electrician may have miscalculated the total load demand of the subpanel and furnace, resulting in an undersized branch circuit. To address this issue, a licensed electrician should firstly install a separate breaker for the furnace circuit. A 40 amp breaker for the furnace should be suitable. Secondly, transfer the subpanel load to another circuit with sufficient capacity. Thirdly, verify that the furnace is operating within its specified current draw limits. It is important to note that this type of electrical work should only be performed by a licensed electrician who is familiar with the relevant building codes and safety regulations. Let's delve deeper into the electrical codes and principles that govern this situation. Firstly, NEC 440.32 specifically addresses the installation of branch circuits for equipment like furnaces and air conditioners. The intention behind this code is to prevent overloading of circuits and ensure the reliable operation of essential equipment. Furnaces, in particular, are considered essential because they provide heating, which is critical for safety and comfort, especially in colder climates. By prohibiting the connection of other loads to the furnace circuit, the code aims to minimize the risk of the furnace being deprived of power due to an overloaded circuit. Secondly, NEC 110.10 emphasizes the importance of ensuring that electrical installations are free from hazards. This is a broad requirement that encompasses various aspects of electrical safety, including proper wiring practices, adequate overcurrent protection, and the correct sizing of conductors. In the context of the described scenario, the shared circuit for the subpanel and furnace creates a hazardous situation because it increases the likelihood of overcurrent, which can lead to overheating, insulation damage, and even electrical fires. Now let's consider the electrical principles that are at play here. Every electrical circuit has a maximum current carrying capacity, which is determined by the ampacity of the conductors and the rating of the overcurrent protection device, such as the circuit breaker. When multiple loads are connected to the same circuit, the total current draw must not exceed the circuit's capacity. If the total current exceeds the capacity, a circuit breaker will trip, interrupting the flow of electricity. In the described scenario, the 44 amp breakers are likely undersized for the combined load of the subpanel, television, irrigation system, and furnace. This means that when all of these devices are operating simultaneously, the total current draw exceeds 44 amps, causing the breakers to trip. This is not only inconvenient but also potentially dangerous, as it can disrupt the operation of the furnace and other critical equipment. Another important consideration is the inrush current of certain appliances, such as the furnace. Inrush current is the momentary surge of current that occurs when an appliance is first turned on. This inrush current can be several times higher than the appliance's normal operating current. If the circuit breaker is not sized appropriately to handle the inrush current, it may trip even if the total steady-state current draw is within the circuit's capacity. When addressing this issue, it's crucial to follow a systematic approach to ensure that the electrical system is safe and compliant with code requirements. Firstly, a licensed electrician should conduct a thorough load calculation to determine the total current demand of the subpanel and the furnace. This load calculation should take into account the continuous and non-continuous loads connected to the subpanel, as well as the nameplate current rating of the furnace. Secondly, based on the load calculation, the electrician should determine the appropriate size for the circuit breakers and conductors. The circuit breakers should be sized to protect the conductors from overcurrent, while the conductors should be sized to carry the anticipated load current without overheating. Thirdly, a separate circuit should be installed for the furnace, as required by an EC 440.32. This circuit should be dedicated solely to the furnace and should not be used to supply any other loads. The circuit breaker for the furnace circuit should be sized appropriately to handle the furnace's inrush current and normal operating current. Fourthly, the subpanel load should be transferred to another circuit with sufficient capacity. This may involve installing a new circuit or reconfiguring existing circuits to ensure that the total load on each circuit does not exceed its capacity. Fifthly, the electrician should verify that the furnace is operating within its specified current draw limits. This can be done by measuring the current draw of the furnace while it is running and comparing it to the nameplate rating. If the furnace is drawing more current than it should, it may indicate a problem with the furnace itself, such as a faulty motor or blower. It is important to emphasize that this type of electrical work should only be performed by a licensed electrician who is familiar with the relevant building codes and safety regulations. Electrical work can be dangerous, and improper wiring can create a significant risk of electrical shock, fire, and other hazards. A licensed electrician has the knowledge, skills, and experience necessary to perform electrical work safely and correctly. In addition to addressing the immediate problem of the overloaded circuit, the electrician should also inspect the entire electrical system to identify any other potential code violations or safety hazards. This may involve checking the wiring connections, grounding system, and overcurrent protection devices to ensure that they are all in good condition and functioning properly. By taking a comprehensive approach to electrical safety, the electrician can help to protect the homeowner and their property from the risks of electrical hazards. To further illustrate the importance of proper electrical wiring and overcurrent protection, let's consider some specific examples of what can happen when electrical systems are not installed or maintained correctly. Firstly, overloaded circuits can cause wires to overheat, which can melt the insulation and create a fire hazard. This is especially true in older homes where the wiring may not be rated for the current demands of modern appliances. Secondly, faulty wiring connections can create hotspots, which can also lead to overheating and fires. Loose or corroded connections can increase the resistance of the circuit, causing it to generate more heat. Thirdly, undersized circuit breakers can fail to protect the wiring from overcurrent, which can result in insulation damage and fires. Circuit breakers are designed to trip when the current exceeds a certain level, but if they are not sized appropriately, they may not trip quickly enough to prevent damage to the wiring. Fourthly, improper grounding can create a shock hazard. The grounding system is designed to provide a path for fault current to flow back to the source, which trips the circuit breaker and de-energizes the circuit. If the grounding system is not installed correctly, it may not provide an adequate path for fault current, which can create a risk of electrical shock. Now let's discuss some of the specific code requirements that are relevant to the scenario described. NEC 210.20 addresses the overcurrent protection requirements for branch circuits. This section requires that branch circuits be protected by overcurrent protection devices such as circuit breakers that are sized appropriately for the ampacity of the conductors. NEC 210.21 addresses the outlet device requirements for branch circuits. This section specifies the types of outlets that are permitted on different types of branch circuits. NEC 210.23 addresses the permissible loads for branch circuits. This section specifies the types of loads that are permitted on different types of branch circuits. NEC 250 addresses the grounding and bonding requirements for electrical systems. This section specifies the requirements for grounding the electrical system and bonding the metallic parts of the system together to create a low impedance path for fault current. By following these code requirements, electricians can help to ensure that electrical systems are installed and maintained safely and correctly. In conclusion, the situation described, where a subpanel and furnace are wired on the same breaker, is a clear violation of electrical codes and poses a significant safety hazard. This issue should be addressed immediately by a licensed electrician who should install a separate circuit for the furnace and ensure that the subpanel load is transferred to a circuit with sufficient capacity. By taking these steps, the homeowner can help to protect their family and property from the risks of electrical hazards. Remember, electrical safety is not something to be taken lightly. If you are not comfortable working with electricity, it is always best to hire a licensed electrician to perform the work. They have the knowledge, skills, and experience necessary to do the job safely and correctly.